This is the third video in the Test 1 review, and it covers material on evaluating trig functions and solving right triangles. In our first problem, we want to evaluate the exact value of sine of 60 degrees. So we can do that through using a right triangle. So we have a right triangle, we have our right angle, and we have 60 degrees. So we know that sine theta is equal to opposite over hypotenuse on a right triangle. So we're going to need this opposite side B and a hypotenuse. So for simplicity's sake, we can just assign the hypotenuse a value. So I'm going to pick 2. And we know with a 30, 60, 90 triangle that the shortest side is equal to half the length of the hypotenuse. So this side is going to be equal to 1. So using those values, we can solve for b. We know using the Pythagorean theorem that 1 squared plus b squared equals 2 squared. And by simplifying that, you should get b equals the square root of 3. So sine of 60 degrees would be the square root of 3 over 2. Eventually, you should start memorizing some of these values, but this is just a quick example on how you can use right triangles to find exact values of trig functions. In our second question, we're given theta equals negative 130 degrees, and we want to find a reference angle. A reference angle is the positive acute angle made by the terminal side of the angle theta and the x-axis. So I'm just going to draw a quick graph of our angle. Of course, this isn't exact, but I just want to show a representation of what negative 130 degrees would look like on a graph. So to find the reference angle, we're looking for this angle here, the positive acute angle made by the terminal side of theta and the x-axis. So the first thing that we need to do to solve this problem is find the coterminal angle. So in order to do that, we're going to add 360 degrees to negative 130 degrees. So that gives us 230 degrees. So that basically gives us this angle. So in order to solve for our reference angle, what we're going to need to do is subtract 180 degrees from 230 degrees. So 230 degrees minus 180 degrees equals 50 degrees. And that is our reference angle for negative 130 degrees. In our third problem, we want to find the exact values for theta equals 300 degrees. So in order to do that, first we're going to want a reference angle for 300 degrees. And we can do that by saying 360 degrees minus 300 degrees, and that gives you 60 degrees. Just as a quick visualization, if we had 300 degrees, our reference angle is going to be this angle right here, which is why we subtracted 300 degrees from 360 degrees. It's also important to remember that with this angle, we're in quadrant 4. So if we're using 60 as our reference angle, then we can start off, we know that sine of 60 degrees equals the square root of 3 over 2. However, because we're in quadrant 4 and sine is negative there, we're going to need the negative square root of 3 over 2 for sine of 300 degrees. So cosine of 60 degrees is 1/2, and in quadrant 4 cosine is positive, so that value remains positive for 300 degrees. Tangent of 60 degrees is the square root of 3. However, tangent is negative in quadrant 4, so our answer for tangent would be negative square root of 3. Cotangent of 60 degrees is the square root of 3 over 3, and cotangent would be negative in quadrant 4, so we're going to have the negative square root of 3 over 3. secant of 60 degrees is 2, and secant is positive in quadrant 4, so secant of 300 degrees is just positive 2. And finally, for cosecant of 60 degrees, that's equal to 2 root 3 over 3. But since we're in quadrant 4 and 60 degrees is just our reference angle, our final answer would be negative 2 root 3 over 3. So remember, we used our reference angle of 60 degrees to find all of our values, but we had to go through and reevaluate everything because really we're looking at 300 degrees, and that's going to be in quadrant 4. So it's important to make sure you're remembering which quadrant you're in, even if you're using a reference angle to solve for your exact values. In this question, we're given a value for secant of alpha, and then we're asked to figure out what alpha would be. So it's important in this question to remember some of our identities. So we know that cosine of alpha is equal to 1 over secant alpha. So we can say that cosine alpha equals 1 over 1.1173429, and if you put that into your calculator, that simplifies to 0.8949 and some numbers. So now that we have our value in terms of cosine of theta, we can use an inverse function on our calculator to solve for alpha. So you can use the inverse cosine button on your calculator, and in that you'll put 0.8949. And once you do that, you'll find that alpha is equal to approximately 26.49 degrees. So your calculator only works with sine, cosine, and tangent, but it's important to remember that we know identities that can put cosecant, secant, and tangent in terms of cosine, sine, and tangent. In this problem, we're given a right triangle and some values, and we're asked to solve for angle M and sides N and P. So, solving for angle M is relatively easy because we know that there's 180 degrees in a triangle. So we have our right angle, so we can subtract 90 degrees, and we also know the angle 41.7 degrees. So in order for there to be 180 degrees, we need 90, 41.7, and angle M to add up to 180, which is why we can just subtract 90 and 41.7 from 180 to find angle M. So when you put this in your calculator, you end up with 48.3 degrees as angle M. So we're going to need to use trig functions to solve for sides N and P. So side N involves the opposite side, and we also know the adjacent side. So the best trig function for us to use would be tangent. So we know that tangent of N equals N over M, which we can then simplify to tangent of 41.7 degrees equals N over 123. So 123 times the tangent of 41.7 equals N. And you can just plug that into your calculator and you get that N equals approximately 109.6 meters. Okay, so we still need to solve for P. So P is our hypotenuse, and we still know an adjacent side. So the trig function that deals with the hypotenuse and the adjacent is cosine. So we're going to use cosine to solve for our side P. So we know that cosine of N equals M over P. So we can plug in our values that we know. We have N, so cosine of 41.7 degrees we know m, which is 123, and we're solving for p. So, to solve for p, it would be p equals 123 over cosine of 41.7 degrees. And if you plug that into your calculator, you get p is approximately equal to 164.7 meters. In this problem, we're given the information that the base of an isosceles triangle equals 38.25 meters with base angles of 39.12 degrees each, and we're asked to find the length of the equal sides of this triangle. So our first step in this problem is we're going to want to draw the triangle just to get a better idea of what we're working with. So we have an isosceles triangle, and we know that the base is 38.25 meters, and we have angles 39.12 at the base. So we're wanting to solve for these two equal sides. We can call them length x. So with an isosceles triangle, we can remember that if you draw a line down the middle, you're going to have two right triangles. So we can use these right triangles to solve for x. So now we're just working with this one triangle. So let me redraw the triangle that we're going to be working with. We have x, we have our angle 39.12, we have our 90-degree angle. And so since this line that we have over here bisected the base of this right triangle is just going to be half of 38.25, which is 19.125. So we have the angle, we have the length of an adjacent side, and we're wanting to know the hypotenuse. So the trig function that deals with adjacent and hypotenuse is cosine, so we're going to use that to solve for side x. So we know that cosine of 39.12 degrees is equal to 19.125 over the hypotenuse. So we know, so simplifying that, the hypotenuse is going to be equal to 19.125 over cosine of 39.12 degrees. If you plug that into your calculator, the side x of the isosceles triangle, which is the length of the equal sides, is going to be 24.65 meters. So in summary for this video, we want to remember that in terms of a right triangle, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we can remember that with SOHCAHTOA. It's also important to remember that a reference angle is the positive acute angle made by the terminal side of theta and the x-axis. And don't forget, when you're working with the reference angle, it's important to remember what quadrant your original angle was in. So this video covered example problems on evaluating trig functions and solving right triangles, and this is the final review video for test 1. Remember that there are 2 other videos in this series covering material for test 1.